In today's lesson, we are going to be looking at the sine wave. Now, this is going to be a specific application of a periodic function, which we looked at in our previous lessons. So to warm up in class, what we're going to do is we're going to make a little bit of our own sine wave using spaghetti. So we're going to use a unit circle here, and we're going to draw a vertical line from the x-axis, or from the diameter, to a point on the circle for each angle. So if I imagine I drew one in red for 15, for 30, and do the same thing for 45, and for 60, again, using a ruler, making sure it's straight. And I'm going to continue for every angle. Next, what I'm going to do is I'm going to break off pieces of spaghetti to match the size of each line that we drew. And then we're going to tape each piece of spaghetti to the correct angle on our graph, making sure that we match the direction the line goes on the graph. So for these ones, because it's kind of above the x-axis or above our diameter, they'd be going up. And the ones, everything past 180, would be going down from our x-axis. And what we want to do is, after we have our visual, we want to see, okay, what do we notice? And what you should notice is that you create somewhat of a periodic function, or you create a wave. Maybe you don't see the periodic function, but it will continue as we extend beyond 360 degrees. So our sine wave graph is a periodic function. So when we do sine of an angle, all the way up to 360 and beyond, it creates a periodic function. It creates this repetition. So for example, okay, let's go and let's add some actual values. Let's draw our sine wave graph. So the x-axis is in increments of 15 degrees. So we have, so we have 30, that's a little bit too thin. So we have 30, 60, 90. I'm going up by 30s just because it's a little bit easier. 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. So basically one full repetition or one full cycle of a circle. Now what we can do is we can go through and do sine of all these angles and get a value. If this is 1 and negative 1, so let's say for example sine of 30, we get half. We can put a point there. We also go back and do sine of 0 and get 0, which would be right here. So 0, a half, sine of 60, we get 0.86 or 8.87. So that might be somewhere right around there, or maybe a little bit lower. Sine of 90, we get 1. Sine of 120, we get 0.87 again. Sine of 50 or 150, we're going to get half. Sine of 180, we're going to get 0. 210, we're also going to get half. Oops, this one's over a bit. 240, or sorry, negative a half. 240, we're going to get negative 8 or 0.87. 270, we're going to get negative 1. And we're going to repeat back up. So this right here, this is our sine wave. I'll try to connect the lines as best as possible, or the points as best as possible. Oops. To make our sine wave. And if we were to continue beyond 360, we would just repeat these values. We would see a repetition of all these points. Putting them in. We'd see a repetition of all these points again, and continuing on basically forever. This is, again, an example of a periodic function. Now, because it's a periodic function, we can go through and we can come up with some characteristics for our sine wave. The maximum value, in this case, the maximum value is going to be 1. That is the highest value we go to. So our maximum. Our minimum value is negative 1. Our amplitude is from the midline, or from our axis, up to our max or up to our min. So in this case, I'm going to draw in my axis or figure that out first, And I could determine it right now, or I could look at it and say, okay, I can clearly see where my axis is or where my midline is. Or, or I can take the maximum minus the minimum. I'm sorry, maximum plus the minimum divided by 2. Get 0 divided by 2, or 0, which again makes sense. We can see that our midline is right, or our equation of our axis is right here. So my amplitude is going to be going from the midline, or from the axis, to my max, or to my minimum. So I have two different spots where I can see my amplitude. And that distance is going to represent the amplitude. It's going to be a positive value no matter what, even if we're going to the negative direction. So we have our amplitude. So our amplitude in this case is going to be 1. Our y-intercept, where does it cross the y-axis? Well, it crosses the y-axis right here. This is our y-intercept. Oops. So our y-intercept is 1, or not 1, sorry, 0. Our x-intercepts, where does it cross the x-axis? Let's see what color we can come up with for this one. Maybe we'll do a bit of a rainbow, or kind of a gold. No, not a gold. Maybe more of a silver. So our x-intercepts, where does it cross the x-axis? So we can see that it crosses at 0, 180, 360. Actually, that is a little bit hard to see. Let's change that up to keep it color-coded. Let's go with an orange. So our x-intercepts are 0, 180, 360. And you can probably imagine where the next one is, right? It's going to be every 180 degrees. Our period, then, is the length of one cycle. So one cycle, I see only one repetition here. So where we start at 0, we go up, we go down, and we come back up to 0. So this entire distance, oops, not that entire distance. So our entire distance all the way up to 360, where our cycle ends, that is our period. So our period is 360 degrees. Our domain, so again, kind of going back all the way to our first unit, the domain for our x values, right? This can be x is any real number. Our range for the y value is y can be any real number, given that y is greater than -1 or equal to, but less than or equal to +1. X can be any real number, even though we only have one cycle here. This can go on in the positive direction. It can go on in the negative direction as well, forever. The last thing we want to do, and it doesn't quite show it on here, the last thing we want to do is identify 5 key points. Right, so 5 key points that we want to be aware of for our sine wave is where it reaches 0, or where the value is 0, and where the value is 1 or -1. So we have 0, 0 for our first point. We have 90 and 1 for our second point. We have 180 and 0 for our third point. We have 270 and -1 for our fourth. And we have 360 and 0. So those are the 5 key points that we want to have for our sine wave, because if I can plot those 5 points, I can easily kind of see I can easily see or sketch the sine wave. So the sinusoidal function is what we kind of just drew or what we just looked at. It is periodical, meaning it repeats, right? It has a repetition of y values, whose graph is also smooth and symmetrical waves. So we call this a sine wave, right? Because it does look like a wave. And it can also be done with a cosine function as well. So we can have a sinusoidal function or a periodic function called the cosine wave. They are slightly different, but they are very similar as well, as you can see here in in this diagram. We're only going to be focusing on the sine wave though in this course. So let's just look at an example. So Sarah is sitting in an inner tube in a wave pool. The depth of the water below her in terms of time can be represented by the graph shown below. And we want to basically determine what is the period, the minimum, the maximum, the equation of the axis, the domain, the range, the amplitude, and 5 key points. So the first thing I'm going to do is the period, but in order to do that, I need to highlight one cycle. So because it is a sine wave, I'm going to start here. I'm going to trace along my function until I get back up to that value on the upwards, and I have it down here. I can now take a look at the period. That is the length of one cycle, and it looks like it is about 3 seconds. The maximum value, so looking at the highest value, which would occur up here. So our highest value looks to be, if each one is 0.2, so this looks to be 2.2, 2.4. So that means our maximum value is 2.4 meters. Our minimum value on the other end is 1.6 meters. The equation of the axis, again, I could look visually and see where the middle is, right? I could probably just take a good guess, or not a good guess, but a estimation, and say that the midline or the equation of the axis is right there. Or I can calculate it by doing the maximum plus the minimum divided by 2, or I get 4 divided by 2, which is 2, which is the same value that we have. So our axis, our equation of the axis is x equals 2, or sorry, not or y equals 2, or just 2. Our amplitude, again, the height or the distance from the midline to the max or to the min. I could also do 2.4, the max minus the min divided by 2. So 2.4 minus 1.6, 0.8 divided by 2, which is 0.4. And looking at that, I can see that's my distance as well. From 0.2 up to 2.4 is a different distance of 0.8 or 0.2 or 0.4. And the same thing from 2.0 to 1.6, that's a distance of 0.4. The domain, this is going to stay the same for all sine waves. X is any real number. There's no restrictions there. The range, so y is any real number. However, there is a restriction. Y has to be greater than the minimum, which is 1.6, greater than or equal to, but less than or equal to the maximum, which is 2.4. And for 5 key points, again, this varies, but we could say 0 and 2. We could say 1.5 and 0. We could say 3 and 0. And we need the points for our max and min. So it would be halfway between 1.5. So 1.5 divided by 2 is 0.75. Let's put them in here. So 0.75 and 2.4. And 2.25 and 1.6. So again, it's just the values of, or the points or the coordinates for our maximum and minimum values. So again, this is just about recognizing the key features and being able to identify specific values for our sine wave or our sinusoidal function. One last example, same idea. We just want to go through and find all that information. Right, our period. We need to figure out one cycle first. So I'm going to start here at the beginning. I'm going to trace until I come back up to that point. Should be there. So my period is the length of that, which would be 4 units, 4 seconds maybe. It doesn't really tell us any measurement, but we'll just say 4. Our maximum, again, relatively easier to find. Our maximum we can see here and here. So our maximum is 10. Our minimum is 2. Remember, we talked about the max and min. We're not talking about the entire point, just the y value. The equation of the central axis, the midline. Again, I can roughly estimate it or draw, or I can see that it's going to start at the midline. So wherever that starting value is at the midline, that is where my axis is going to be. And in this case, it is going to be 6. I could also determine it by doing the max plus the minimum divided by 2, or 10 plus 2, which is 12 divided by 2, which gives us 6 again. And then lastly, the amplitude. For our amplitude, again, it's the distance from the midline or from the axis to our max or our min. I could visually just count it here. It does look to seem relatively a nice number. Or I could do the max minus the min divided by 2, 8 divided by 2, which is 4. And again, I can see the same thing from the graph. So again, it's all about just identifying these key features, which we talked about with periodic functions, but looking at it now with sinusoidal functions, which is a family or a specific characteristic of, or a specific type of periodic function.